Okay, so a little review on topographic mapping. Got a little vocab. All right. We measure things in a field on a field map. It's an area where we can map something, temperature, pressure, whatever. All right. Elevations, distance above sea level. We measure that in feet or meters. A little generic term, isoline, is some line connecting points of equal value. Iso means same. All right. If we're talking about elevation, an isoline is called a contour line if we're talking specifically about elevation. So you might hear me say we're making contour maps. Right? That's basically a map of elevations. Right? The difference in elevation between two adjacent contour lines is your interval. If we see a contour line that has little tick marks around the inside of it, that's showing a hole in the ground. Those are called depression lines. And then generally speaking, if we want to label the lines so we know what we're doing, they usually make what's called an index line. They make it a little heavier, darker, and that's the one usually put the numbers on. They don't normally number every single contour line because it would get a little too crowded on the map. So we only usually label every 4 or 5 or whatever, something like that. Here's an example, all right, little mini map. If we look, the little line with the tick marks on the inside, that's what we call a depression line. Those tick marks are called Hatcher lines. That means that that's a hole in the ground. Okay? Regular old contour line, just kind of a light line with no lines, no line markings on it. And then the darker line that has the number, that's what we call an index line. So if we take a look at the value of each of these lines, so the bottom dark line is 200, the top dark line is 300. That means that each of those little lines in between those arrows, there's going to be 20 feet. Okay? Each line. So the next line up would be 220, then 240, then 260, then 280, then 300. All right, scales. We have 3 basic types of map scales. We have what's called a verbal scale. Verbals because you say what the relationship is. 1 centimeter is equal to 4 kilometers. We can actually write it as an equation. Right? It's still a verbal scale, but we still say it the same way. 1 centimeter is equal to 4 kilometers. What that means is that gives us what we call our multiplier. Right? So if we know that every centimeter on that map we're looking at is 4 kilometers, we just take whatever measurement we have on the map and multiply by 4. So if I measure out 2 centimeters, I know that that distance really is 8 kilometers long. Right? It's a nice little way to do a relationship. Right? A graphic scale gives a little bar. Usually they separate pieces or chunks of the bar with dark light boxes. Right? So if we know that entire line right there is a mile long, and there are 5 boxes in between those, we got 3 black and 2 white. Okay? We got 5 boxes there. So 1 whole mile divided by 5 is going to be 2/10 of a mile per box. 1 divided by 5 is 0.2. Right? 1/5, but remember how I feel about fractions. Right? So 1 over 5 is 0.2. So 0.2, 0.4, 0.6, 0.8, and 1.0 miles. That's a graphic scale. So if you want to use that, you just take a piece of scrap paper on your map, mark a couple of points representing the length you want to measure, and then lay it on the scale and compare your lengths. And then finally we have what's called a fractional scale. You can use either a divide sign or a colon, and all that means is that 1 unit, whatever that unit may be, 1 unit on the ground is equal to 25,000 units actually on the Earth. Right? It just means that the Earth is 25,000 times bigger than that map that you're working with. And it doesn't matter what unit you use. You can use inches, you can use centimeters, whatever. I like to use centimeters because we use the metric system in here. So that tells me that 1 centimeter on the map is equal to 25,000 centimeters on Earth. Okay? And we can actually convert this over back to a verbal scale to make it a little easier to work with. All right? So if we take that relationship right there, 1 centimeter is equal to 25,000 centimeters. And if we convert the centimeters on the right into kilometers, it'll make it a little easier to work. Right? If we know that there are 100,000 centimeters in a kilometer, we can just take the 25,000, divide by 100,000, and that means that 1 centimeter would be equal to 1/4 of a kilometer. That's a little easier to work with. right? I'm trying to do it in centimeters. So if I knew that the distance that I was looking for on the map was 2 centimeters, then I know the actual distance is a half a kilometer, 0.5 kilometers. Right? All right, so what do we have? What are we looking at here? All right, well, this is a top-down or a bird's-eye view of an island. All right, and you can see that we've got a peak here, which is a little bit higher than 3,000 feet. We've got a peak here that's higher than 3,500 feet. And we've got a peak here that's higher than 2,000. So we've got 3 peaks on this island. We've got some rivers running downhill toward this ocean or this body of water. Okay? And how do I know which direction they're running? Because I look at the V as the contour line crosses the water. Notice it makes a little V, and that V points in an uphill direction. So it points toward higher elevation, so this must be lower elevation down here. Higher elevation up here, lower down here. All right? So if we turn it on its side, so let's look again. Okay, this is our top-down view. Here's our side view. There's our 3 peaks. There's our 3 peaks from the side. And you can see the elevations are a little over 3,000, a little bit under 4,000, and a little over 2,000. Right. So again, how do we kind of work with this? What are we doing when we talk about these? Well, when we want to make contours, we need to pick our interval. Right. First thing we want to do is trace a line around the water level, okay, sea level. Right. This is our starting point. 0 feet of elevation is sea level. Right. Now again, if we were to turn on the faucet, so to speak, and fill up the oceans, and I'm going to fill it up to an elevation of 500 feet. I'm going to use 500 feet as my contour interval. So when that water gets up to 500 feet, then I walk around the island again and I paint another line. And I keep doing that every 500 feet. Okay. Now, if I do one more, that middle peak will be underwater because it's only at 39.98, and the next line would be at 4,000. So now I pull the plug, drain the water, and I'm back looking with something like this. I've got an island again, and I've got a line drawn around the island at intervals of every 500 feet of elevation. And then if I turn it back, I'm back to where it came from. So that's where it came from. That's how we got those lines on that map. It's almost like painting a line around at the elevations. Now, obviously, we're not really doing that, okay? But it's just to represent what we're talking about. Right? This is called a contour map. It's not called a topographic map yet. Okay? It's just called a contour map because all it's showing is contour lines. It doesn't have other features like buildings and swamps and all that kind of stuff that are on actual topographic maps. So, all right, so onward. Gradient. All right, steepness of a slope is the gradient. And if you remember, we have our reference table here. Okay? You can see that gradient is the change in field value over distance. And we use this kind of delta FV over D as our little shortcut because I'm lazy here. So there's our gradient formula. Gradient is how steep the slope is. So when you look at these 2 pictures, you got 2 mountain peaks here, one on the left, one on the right. Okay? Obviously, the one on the left is steeper than the one on the right, and we could actually figure out, if we calculate the gradient from here to here, and then from here to here, you can see that this slope is steeper than that slope, so this is going to have a higher gradient than the one on the right here. All right, over here. How would a steeper slope be shown on a topographic map? Well, close contour lines. If I were to put a compass rose right in the center of this, right there, this is the north side of the mountain, this is the west side of the mountain, this is the south side, and this is the east side, we would know by looking at these lines that the east side of that mountain is the steepest. All right, so what do we get from this picture when we look at it? Well, we can get the elevations because we can figure out what the lines are. There'll be something that'll tell us what the line value is worth, so we can figure out the elevation. We can see the shape of this is kind of an elongated hill. Starts here, and it goes up gradually to a peak, and then it drops down very steeply on the eastern side. So we get the shape, and we can figure out the gradient just by using this formula up here, change in field value over distance. All right. Change in field value would be your gradient. What is the value of each of the lines when you subtract them? And then your distance is a horizontal measurement between the two. All right, a little contour line practice. All right, drawing contour lines at the following elevations, all numbers are given in feet above sea level. So let's change this so we can see a little better. Let's do blue. All right. So this is what I want. I want 3, 4, 5, 6, and 700 feet. You can start at the bottom and work your way up, or you can start at the top and work your way down. I'm going to start at the top and work my way down today just for something different. All right, so I'm looking for 700. So here's a 700. Here's a 700. There's one. And I think that's it. All right, so when I start drawing, I get here, I don't have any other 700s, but if you look, I've got a 650 there and a 750 there. There must be a 700 right between them. Same thing here. Now, 600 and 750. So there's actually a 650 here and a 700 about here. So I know there's one right about there. 650 and 700, I know there's one right there. And then I can keep going. This is the highest marked elevation on my map, okay? 750 right there, all right? We don't have that line, so don't read it there, but, okay? So this is the peak of our mountain, so to speak. Now we're going to do the 600. All right, well, there's a 600, there's a 6, 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 there's a 6. So we start here. Notice we're going to go between those. Keep going now. We've got to count for this one. We've got to count for this one down in the lower left here. So we can go off or come back on, or we can actually fit. So it probably does this nice and easy right through there like that. And there's our 600. Now we want a 500. There's 5. There's a 5. There's a 5. Another one. Another one. All right. This one's definitely going to go off the map because remember these contour lines kind of sort of parallel each other. All right. So this one's going to start over here. Now 450 here, 550 here, so it's going to come back between like that. Keep going. And off that side like that. And there's our 500. 400. 400. Oh, there's one there. There's one. There. So we don't have anything down here to work with, so let's just start up here like this. Okay? Through that like that. 350, 450 in between all those. And then right off the other side, there's our 400. And yes, it probably comes down here somewhere, but we don't know for sure. Okay? Now we want our 300. 300 there, 300 there. That's it. So watch this. That's easy. Done. All right. Here's the peak of our hill. And as you move out in all directions, doesn't matter which direction you go, notice it's going downhill. Okay, so that's the peak. All right. All right, so now we're going to calculate gradient from point A to point B. Let me clear up a little space here so we can see what we're doing. Change the color to something different. Oh, green. Okay, so point A is right there. Point B is right there. Gradient, change in field value over distance. Well, A A is 650, B is 300. So our difference is 350. And we're measuring in feet above sea level. So we're going to have 350 feet. And then we take a piece of paper and we measure the distance from here to here using our scale down here. Okay? And if I do that, it looks like it's about 10 kilometers. I would actually take a piece of paper and measure it, but it looks like about 10, so I'm going to go with 10. And then when I divide it, I'm going to get 350 divided by 10. It's 35 feet per kilometer. Okay? That means as I walk, if I were to walk from A to B, on average, the elevation would drop 35 feet every kilometer that I walk. Just an average. Okay? All right, let's clear this up. All right, law of V's. We have a stream. Remember, as the contour lines cross a stream, they make a little V, and that V points uphill. So those V's are kind of pointing to the left, which means the left side of this, way over here, is going to be your higher elevation. Over here is going to be your lower elevation. The water flowing out of the V means it must be flowing to the right. If this were a traditional map setup, we don't have anything to gauge it by, but if it were a traditional map setup, we would say this stream is generally flowing to the east. Okay. All right, reading a topographic map now. All right. At what end of the park is the ranger station? Well, ranger station is over here. If you look at our north, east, south, and west right there, if we were to take this and plop it right onto our map, we would see that we are in the southeast corner. All right. How many trees? Count them. 1, 2, 3, 4, 5, 6. Okay. 7 looks like. All right. At what elevation is the ranger station? Well, when you look at the elevation, here's a 450 line right here. Here's a 500 line right here. It's between 450 and 500, but it's actually a little closer to 500. So maybe 490. All right. What's the elevation of the bridge? Bridge is right there. This line is 700. This line is 750. About halfway, maybe 725-ish. How many cabins are at or above an elevation of 750? Well, inside the line here is above 750, so we've got 2 cabins in there. How high is the highest point in the park? Here's our hill. This little point here is our highest point, so that's 1,050 meters. What features in the northwest corner? There's the northwest corner. See those little contour lines have little tick marks on the inside, so those are hatcher lines. That's a depression or a hole in the ground. Okay. How long is the path that takes you from the ranger station to the lake? Well, you have a scale right here. Looks like 2 centimeters is equal to a kilometer, or 1 centimeter is equal to half a kilometer. So you measure from here to here, here to here, here to here, 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 here. Add them up, figure out what they are in centimeters, and then multiply by 0.5, and that would give you the actual distance in kilometers. All right. What is the contour interval? Well, 450, 500, 550, 600, 650. It's a 50-meter interval. All right. And then what topographic features in the southwest corner? You can see that there's no tick marks on this, so it's just a hill. All right. Topographic feature, not man-made feature. Right? Okay. Hill. All right. And then finally, we want to make a profile. A profile is a cross-section. All right. So if, for example, you look at what we have here, if you were to take a piece of paper and lay it across your profile and mark each place where the tick mark touches your paper, and then put its value, And then bring that paper down to a vertical scale, and notice the vertical scale is the same as your contour interval. So this mark is 0, so we put a little X or a tick mark or a point or decimal or something. We go up to that, it's 20. We go up here is 40. Here is 60, 80, 80, and then we're going back down 60, 40, 20, 0. And then we start connecting the points. Notice when we get to the top, we have to go through it and back down to the same point. And then we finish off right there. There's our profile. All right?